Hello.
Hello, can you hear
Hello,
me well?
Elias. Well,
Hey guys, hey.
Oh,
How's it
guys,
going?
can you guys hear me?
Yeah,
Cool.
Okay, welcome to everyone. So can you each kind of give an introduction? How did you get into crypto and ZK specifically? Elias, do you want to kick off?
yeah, sure. Um, I started crypto in I think 2018, 2019. I was in Singapore for an exchange abroad at the time. One of my friends was aping into Bitcoin, and he convinced me just to buy some ETH. I was actually a normie, like I bought just Ethereum on Coinbase at the time. I wasn't a dev yet, and then a little bit after, became a software engineer. Thanks to friends from Math Uni. And later after, like a year after, when I was looking into the Ethereum ecosystem a lot, they introduced me to zero knowledge technology. So first I started with Circom, and now I'm fully start built. So I'm exclusively in the Starknet ecosystem and handling with Starks. So that's it.
Okay, who wants to go next? Maybe
Okay,
Dirk?
I'll give an intro if no one's gonna go. I'm Carter. I'm the founder of OAS. So we're a layer two, like our other panelists. We have our own, I guess, smart contract protocol. So we're not using EVM. We're actually a ZK native protocol. So like you can imagine, all of our contract functions are actually compiled directly to unique circuits. Yeah, my crypto journey started when I was a bit younger, at around 2015 or so, primarily because I was accepting payments via crypto due to the nature of some of the work that I used to do. But yeah, no, it's great to be here. Thanks so much to the organizers.
Thank you.
All right, I'll go next. Thanks for having us. My name is Dirk. I'm now a director at Consensus doing BDN strategy. But before joining Consensus, I did traditional finance for quite a while, 3 years investment banking and bulge bracket, and 4 years of private equity investment and large funds. So for crypto, I started doing crypto investment personally approximately 5 years ago, but professionally approximately 2 years ago with a primary focus on infra. That was when I started paying attention to zero knowledge. And obviously, after joining Consensus, I got amazed by Linea's vision of becoming the best high-performance roll-up solution on Ethereum. So I raised my hand to become part of the Linea building effort. That's pretty much it.
Thank you.
Great. I can be next. Yeah, so I had a pretty similar experiences, but from a different background. I was from more like a technical and academia background. I get into crypto when I was doing a PhD in computer science at the University of Washington, Seattle. And I actually organized the first cryptocurrency and blockchain seminar back in the day in University of Washington in 2018. Then in 2019, I graduated from the PhD program. I decided like the best way to learn a thing is actually into the thing. So I joined, my first job was at Algorand, a cryptocurrency company located in Boston. And I was spending 1 year there and learning a lot of cryptography and hang out with a lot of great cryptographers, including the sort of father of zero knowledge proof crypto, Sylvia Mechani himself, and just kind of getting into ZK rabbit hole. That's it. Yeah. And just a little bit brief intro of Poseidon, right? We're building a ZK aggregation infrastructure on Ethereum. Think about, we take a batch of any kind of ZK proof you can imagine, like Stark, Snark, we don't care. And we can like aggregate the batch of proof into a single proof. So you get a much better throughput and also latency. So, and also more importantly, you get much cheaper gas cost. You're thinking of us a ZK aggregation engine for Ethereum. That's what we're building right now. Yeah.
Okay, thank you. And so I'd like to first ask Kakarot and Linea. There are already solutions, say ZK Sync, Polygon, as relative newcomers. How do you intend to compete?
I can go first. I mean, just like in the previous cycle where all the layer ones coexisted for quite a long time, we don't think that in the next bull run layer 2 solutions will be engaged in a zero-sum game of competition for sure. So everybody should work together to better address the scalability issue of Ethereum dApps. We just need to grow the pie through a joint effort. That's the short answer. As for Linea itself, I obviously, am willing to share a few crystal clear highlights, especially if we put ourselves in developers' shoes. So number one being Linea is backed by all those consensus family tools, which you guys are very familiar with, such as Infura, Truffle. Infura as a node service provider has a strong track record to handle the highest maybe concurrency in the blockchain world historically. Therefore, with the support of Infura, Linea will absolutely not encounter the serious congestion problems that some of other ZK rollups face today. Number two, just a reminder that Consensus also has another product called MetaMask. It's a wallet which will be progressively and deeply integrated into all aspects of Linea as well. So for all projects on Linea, this will provide an unparalleled opportunity to distribute your products to over north of 30 million MAUs today. Number three, there will be an ecosystem that we have initially built during the testnet phase. So when you have time, just feel free to take a look at our portal. It includes all well-known DeFi OG projects and a lot of super exciting, innovative Linea native new dApps. So ultimately, we will hope to form a long-term attraction for real end users.
Thank you.
Yeah, I guess the roll-up space is really exciting right now. What I'll say is, I don't think so. It's really cool that Polygon and ZK Sync are in prod, but everyone is in alpha. That's what I think. Everyone is in alpha. Adoption is still quite low. So optimistic rollups still have the biggest share of the pie because they are fast, they work well, they're cheap, and so they're what users want right now. And our considerations are tech and ZK, like Maxi's considerations, such as they're not safe or fraud proofs or not what they claim right now is non-relevant to end users. So I think when I think about ZK rollups, I think the game is still on. I think everyone is in alpha. Everyone is every week improving their proving infra, the sequencer. Right now, Polygon sequencer is very slow. Even Starkware sequencer is slow. And everything is going to get way better within the next year. So I think the real game is played within the next 300 days, maybe 600. And the space still needs to stabilize. That's kind of my take. And there's no better way to test than in prod, I guess, to improve things. So they did a very smart thing. They went in prod while being not really ready, and then call it alpha so that people don't like shoot up the TVL too high. And then they improve and have real data. Because I guess when you have a testnet for a year, it's not real user, it's not real money. So everyone needs to go to prod. Everyone needs to advertise that this is really alpha. And then everyone needs to stabilize their ZK tech. And it's good for the space. Like the more, the merrier. As you said, Dirk, we grow the share of the pie together and we collaborate. So I think that's great. So I look forward to us, Linea, Kakarot, all the ZK VMs going to prod early next year or before next year, I guess. And it's going to be great.
Thank you. As a Shumo, what's your take on that? And how does Poseidon fit into this?
Yeah, so I think I just want to drag people out of this like L2 wars a little bit and thinking the bigger picture, if I may. So I think there are two kinds of scaling, right? One is called horizontal scaling. It's just like building another layer. So you basically replicate what EVM does in the layer 1, you build a layer 2, layer 3. There's kind of like an infinite layer of towers you can build. And what we're building here is we call it vertical scaling, right? So because we think in the year to come, ZK verification will be a huge bottleneck for the entire Ethereum ecosystem. And we think there are many, like tens of thousands of ZK proofs that are going to need to be verified on chain. And that's, so basically we focus on this specific problem and we want to do one thing and do one thing well. Basically, we can scale the ZK verification through proof aggregation on Ethereum. Right. I think for that, we actually see a huge demand. So thinking of if you are a ZK DID builders, if you want to attest people's identity on chain, like every single person need to put a ZK proof. And currently, like roughly speaking, you need about like a 200K to 400K gas fees. And unfortunately, if you are using Stark, it's worse, right? It's about like a 3 million to 5 million gas fees, right? So this is and if you can do the calculation using today's GWay price, how much ETH you need to pay, right? So we did a rough calculation about the scale. You need to pay like a $20 in terms of gas fees, and for all the ZK DID projects, that's your user acquisition cost. We do think by providing like ZK aggregation technology and building as an infrastructure middle layer, and also we can deploy any Ethereum layer 1 or layer 2s, right? So we can bring the sort of ZK on-chain to the masses. So that's what we're building. I mean, I'm glad I'm not competing with all the layer 2s, right? So that's also one of the good things for what we're building right now. Yeah.
Carter, any thoughts on that?
Yeah, absolutely. So I guess I would first say that like your witness generation needs to be scalable in order for your proving system to be scalable, right? So fundamentally, like with EVM, it's just not going to happen. Like within a block, I could deploy a transaction and then, or deploy a contract and then have another transaction in the block, like call that contract. So there needs to be like clear ordered execution. So like when we talk about scaling, I think it's just very important that we also ground ourselves in like, what do we think that scaling is? Like, are we talking about 1,000 TPS, 2,000 TPS? Because for like the vast majority, if we're talking about like web scale use cases, like that's not very much for these people, right? So like what we're building, so we have like a fundamentally different state model. Like I think there is definitely use cases for EVM, but like within the ZK space, I would say that there's also like, you know, sort of two different groups. So right now we're the only member of group 1. So we have global state, and then we also can scale horizontally. So we can guarantee that transactions within a single block, like, you know, cannot conflict with each other or cannot affect each other's execution. This is just something that doesn't work with EVM. Just like the fact that in any Ethereum transaction, I could potentially read or write to any storage slot on chain via, you know, I can make external calls or whatever, right? Like the only way to decide like where state is going to be in conflict, like as we've seen with projects like Aptos, is just by running them. And then when you do that and you try to like back off, it kills your scaling. They claimed 100,000 TPS and their max that they've ever seen is like 70. So yeah, I don't know. I think it's very interesting, you know, especially as like recursive proving gets a lot faster. It'll be interesting to like see where like the limit is. I mean, we've done like a lot on ourselves, and we see there's like an attraction point that sort of forms, because you can always like reduce the degree of the proof by like recursively proving over and over again, but there's kind of like a minimum amount of constraints that you need to do like any proof system. So it'll be very interesting to
ZKVM. I mean, there are many, but in architecture way, you can. There are some people doing signs in the crowd. Maybe they don't hear or something. I don't know. Never mind. Anyways, so you can build a ZKVM by rewriting all the opcodes as circuits, and then you prove execution by like taking every transaction and then proving them. So That's what Scroll is doing. That's what Linea is doing. So you build kind of a backend around the EVM that allows you to prove any transaction that's been executed. And for Kakarot, what we've been doing is emulating the EVM from within a zero-knowledge virtual machine, which is the Kero VM. So essentially, the Kero VM is a virtual machine that outputs like provable execution traces. So whatever you write in the Kero programming language, you can thereafter prove it with Starks. And so we wrote the EVM in the Kero VM, like in Kero. So if you write an EVM in Kero, you have a ZK EVM. So it's kind of like you build a ZK virtual machine, then you build the EVM on top of it, you have a ZK EVM, or you take the EVM and then you build a way to prove all the things that go within that EVM, and then you've got a ZK EVM. So that's kind of where we at. So our choice was we add a new approach to the ZK EVM space, and the more the merrier. We have more research, applied research. And also we truly believe that the Kero VM is one of, if not the fastest, or like the most promising ZK virtual machine. So yeah, in that sense, we're looking to scale our solution and have hopefully the best results.
Okay.
Just maybe quick question. So like, why do you use a ZK like VM at all? Like, why not? So for instance, like what we do is we just generate like circuits for a contract, and then you can imagine you can like identify like which proof you're verifying by like hashing the verifier data, and then you get much more succinct proofs with way less constraints than like a massive VM circuit. So I'm just curious because it does seem like you've kind of taken the opposite approach to go like more, I guess, more abstract to build even on top of these layers. But like, why do you think, because there may be a good reason behind this, like, why do you think that VM is the right solution rather than, maybe exposing like a delta Merkle proofs like start and end root in the public inputs of a proof?
So I'm not sure I understand your question.
Like why use a ZK VM when you can just like, so for any kind of like transaction, right? Essentially what we're trying to do is prove that a state transition was legal, right? So we have like a start and an end Merkle root, right? And there's like some, we can use constraints to connect those two together, right? And we'll only be able to generate a proof if our delta Merkle proofs values correspond to what is acceptable based on the logic of the circuit, right? So why do we use why do we need to emulate a virtual machine when we can just like so what we do is we symbolically evaluate like the code for each contract function, build a specific circuit. And then because now recursive verification is very fast, we can just recursively verify, prove that this verifier data exists in the contracts like whitelisted Merkle tree, and we're in business. So I'm just curious, like, do you feel that like recursive, because it seems to me like there is an argument for it. It's if recursive will forever be slower than the larger circuits, right? Like, is that sort of like the cost benefit analysis that you guys are making?
No, I don't think so. So maybe there's some subtleties that I've not explained. So you could prove every opcode, like as you said, every function, and then evaluate which a transaction uses, and then generate a proof. But the Kero VM is actually quite like slim, and you can also do recursive proving. There's no circuitry per se, and we already use recursive proofs. So for example, currently in a batch, what we have is a batch is approximately, like say 100 blocks, and every leaf is 1 block, and we recurse them. We do recursive Stark proofs. So we have 100 leaves that amount just to 1 Stark proof of the whole batch of 100 blocks, and then we submit that to L1. So I'm not sure. So
yeah, so what I'm saying is not that we make opcodes, that we make a gap. It wouldn't be a circuit, right? We're not going to do a recursive verification for each op. That would be very, very long, right? Because that's ridiculous. We do a symbolic evaluation of the code. So you can imagine that you actually don't need to implement it as a virtual machine. Like a zero knowledge proof is not a Turing machine, right? A zero knowledge circuit rather is not a Turing machine. It is at best vector constraints, usually like some kind of polynomial constraints, right?
Yeah.
So like you can imagine that you can constrain the public inputs by symbolically evaluating. Like you can make, like a binary syntax tree. For some cases, you can do that. If you have for loops and other things, you have to use special tricks. But you can imagine that for some pure function that's very easy to evaluate in the very base case, that I could like generate some expression for what the outputs of some function should be just by symbolically evaluating it, right? So in those cases, my circuit is just a bunch of constraints. Like I don't have to deal with opcodes. I don't have to do any like Merkle proofs whenever I'm accessing stuff from RAM, because anyways, like this is I guess the difference in strategy. But no, I think it's very interesting because also you guys have gone the abstraction route, which I think makes a lot of sense, because in the future you guys can just kind of pick the winner of the ZK wars and just deploy to them. So yeah. I think that makes a lot of sense. But yeah, I don't know. It's very interesting approach.
Yeah, we have that.
Dirk, do you want to jump in here on what Elias and is saying?
Yeah, sorry, just one question for Carter. What do you mean by symbolic evaluation? Are you guys generating the circuit on the fly?
So we generate the circuit at compile time. So when you compile a contract, there's a bunch of different contract functions, right? And then we generate the circuits for each function, hash the verifier data, make a Merkle tree. Merkle root gets deployed on chain. Whenever you call the contract function, you have to first, during the recursive verification, you also prove that the verifier data you input exists in that contract Merkle tree.
And maybe that's why I don't understand. When you compile a Solidity contract, you essentially end up with bytecode, and these are representing opcodes. So
so we don't compile Solidity. So first of all, like I guess I would butt in and say that so first of all, we support JavaScript contracts. We are able to do symbolic evaluation. There is the case like certain cases where you have indeterminacy with the number of constraints per circuit. However, because we have a Merkle tree of all the whitelists, right, we could just generate different permutations of the circuit and then fall back to recursive verification for, like, let's say if you have a very large amount of logic within the inside of a for loop that we can't automatically vectorize. However, there's tools like, I don't know if you guys are familiar with like SMTlib or Z3, which let you like generally condense or simplify like this kind of logic. Like it's also pretty good at vectorizing now, because you can we could compile to SMTlib2, compile to LLVM, then run like LLVM opt, which will vectorize and they have the best like optimization, and then we can lift back up to Z3 and then back up to our constraint system. So it's actually like, yeah, it's pretty good. We're not generating like assembly. However, like using frameworks like Triton, so I come from the security, like the reverse engineering community. We've had symbolic evaluation for like x86 and ARM for like so long. Like you can generate like an AST for a register after like, you just give it like the x86 subroutine and then tell me, okay, what is like EAX? Give it to me symbolically in terms of my virtualized memory. So you can generate an AST for like any execution that you want. And then if you have an AST, then of course it's very easy to like generate constraints for it, because you just do it like a depth first evaluation of the tree. So yeah, it's not so bad.
Yeah,
we're not working with EVM though. Like we don't believe in using like registers or constraint numbers that are larger than our field size, because it makes everything horrible and slow. But that may just be our humble opinion.
Yeah, that makes a lot of sense. Yeah.
I'll go on, Shumo.
Yeah, just want, yeah, I mean, this is remind me, I was tooling Z3 performance for roughly about 6 months at a certain point in my life. I think my take on that is that the devil's in the details. Z3 is this kind of a magic solver. If everything works well, it works well. And sometimes you have to deal with very unpredictable solving times while during the compilation, right? So you're basically putting a solver in the compilation pipeline. So I would really love to see how well it goes. Yeah.
Yeah, just really quickly, like, so we only do it for larger circuits because you're absolutely right. Like, it can be very unpredictable. Like, it's not clearly bounded, like the time. Yeah, if you guys have any suggestions, we're also welcome. Please help.
Any suggestions?
Yeah, maybe I will pick on Mike. I think one of the things here is that there are other kind of symbolic execution engine, right? So for example, in like a LLVM, is that called Flea or Clee, right? So there are other sort of less powerful, but something you can get maybe not as good as a result, but you get more predictable runtime, like a more predictable, like a solving time, like symbolic execution engine, and also more sort of closely coupled to the compilation pipeline if you are using LLVM, right? So, so have you guys thought about this kind of approach? Or
Yeah, so we're actually not using LLVM. So we're not like a LLVM like ZK VM. So there's a tool called Triton that lets it has one-to-one parity from like SMT-lib2 to LLVM. So we can just run like, it's just the laziest way possible to get like good vectorization for loops, which is like very important if we can do arithmetic that's very cheap, right? Like you can imagine where I'm adding one in a for loop a bunch of times, I can actually just constrain it to be like a multiplication. So like LLVM just makes that easier. It's kind of a hack. For like simple contract functions, we actually don't even run any optimization because like proving takes like 4 milliseconds. So it's, it's like, but anyways, I think it is a long-term decision that we made though, just as a project that like, it's better to have like 10% better proving time and 50% longer compilation time, right? Because you only have to compile once. So yeah. Yeah, very good food for thought. We've been looking at some other solvers, like we use the Triton project, so they also have some other like simplification strategies. But yeah, if there's anything that comes to mind, please let us know. We're always looking.
So that's a Stanford project, right? The Alex.
Yep, the legend of reverse engineering community. So yeah,
I see. Thanks.
I know that there's this battle tech stacks, Snark versus Stark. So what does everyone think about this?
Yeah, maybe I can open the conversation. I think in my view, it really doesn't matter. So for two reasons, right? So first is that in the modern ZK Snark community, we have developed a modular way of thinking about how the zero-knowledge proof system in general should work, right? So there are like a kind of you can roughly divide that into sort of 3 pipelines. The first is arithmetization, and you can have like a circum-ish like R1CS, and you can have Plunk-ish, and this is using by Plunk, Halo 2, a lot of ZK event uses. And then you can have like a Stark-ish. I mean, but arithmetization is really not tied into the like air, right? And then you have the like a polynomial ILP, right? You're thinking about this is a compiler to compile these arithmetizations to polynomials. And then you have Plunk ILP, you have like other kind of ILP, and then you have a polynomial convenience scheme, for example, like a Fry, KZG, and others, right? So it's really like, so for example, if you just in the Plunkish systems, you just replace the KZG to Fry, then you kind of get some proof system like Plunky 2. And Plunky 2, you can call it Stark because the entire security relies on Fayette-Shamir transformations, like random oracle model, and also just like hash functions. So essentially, this is Stark, right? But you can also, if you want to choose a different kind of trade-off point in the performance, if you get like a slightly or depending on what the circuit is, you get longer proving time, but you get constant verification time on smaller proof size, you get Snark, right? In my view, these are all technologies, and you should be using the right place. And I think it really doesn't matter for the end users. I think but I think in a long-term point of view, like quantum resilience is a problem. But I'm also very bullish on the snark community on quantum resilience, because there are new tricks. For example, you can have like a homomorphic groups from the lattice, right? So it can kind of simulate what the curve does, right? So I don't think this is I don't think quantum resilience either in the short term or long term for both Stark and Snark community will be a super big issue in my view. Yeah.
Okay.
Love to hear
just to hop in there.
from others.
So Plonky 3 will support snarks and starks and a bunch of different IOPs, and basically it's kind of like sort of like pick your favorite like trade-off. So I think in the future, probably just going to be people use like one library to sort of define like their I guess abstracted like circuit, and then you could just target whichever scheme you like.
Yeah, I agree on those views. I agree that we don't really care.
Really matter.
So yeah, I mean, I guess snarks were really used because the proof size is very small, and you would essentially want that because L1 gas cost is very high. So it's always nicer to verify snarks on L1. I guess they arrived a bit sooner as well, so they have a precompile, at least for Gross 16, I think, not Halo 2, but anyway. And so yeah, I mean, there are many contingent things, like snarks got a lot of hype because Circum and other libraries were the first ones to go kind of mainstream, so people learned them, and then they became kind of these names that encompass a lot of things. And then since there's two of them, we kind of invented a fight between them. But yeah, all in all, I think even Starks, you can augment the proving time, increase the proving time to reduce the proof size. You can do many things. So I know, for example, for StarkNet and Kakarot, when we do recursion of Stark proofs, we have small proving time but high proof size for the leaves, but then long proving time for the final step, so that we reduce as much as possible the proof size. We chose not to have snark at the last step. So for those who don't know, Poseidon ZKP, for instance, proves everything, proves their EVM and transactions with Starks. But then the last step of the recursion, they actually bundle their Stark into a snark so that the proof size is very small, and then they verify that on mainnet. So I guess with that example, we can see that it's very modular. You can mix and match. As Carter said, you can pick your trade-offs. You can pick your trade-offs between proving time, proof size, commitment scheme, quantum resilience, the ability to upgrade it. So maybe if it commits to L1 mainnet, you would want to not upgrade it every week so as to not hurt your credibility to the users. So yeah, so I mean, it's the old boring software engineering thing. Pick your trade-off and know in advance what you're getting into, but it's all about picking a technology and using it as a tool, and really bear in mind that we're doing everything for end users. So yeah.
Dirk, do you have any thoughts on this?
Yeah, totally agree. That it can be super modular, because obviously both tech routes have their pros and cons respectively. And for Linea, we're quite chill and quite relaxed about this, because we actually have our own in-house proof technology that is different from other ZK EVMs in terms of arithmetic scheme. So Linea basically relies on lattice-based cryptography and error correcting nodes, and we think that it's technically can be a little bit faster than the popular elliptic curve cryptography, and it can be slightly more resilient to quantum computing attacks, things like that. And most importantly, we hope that by putting together right components, we can be we don't need to face the trade-off that with traditional hash functions, you have to choose between whether or not they're fast to run or friendly to use in a snark. So that's our take. Just we have our in-house proof technology, and hopefully that can deliver the same results as well.
Does it mean it's a snark or a stark, or neither one?
It's neither.
Okay.
So in general, though, I think maybe like there will be a winner, though, right? Because like right now, when we're just doing it mostly CPU like based like proving, it may be the case that, because I don't know like very much about hardware. Maybe you guys know more than me and you could tell me I'm wrong. But it may be the case that certain strategies may be easier to implement as like ASICs or on FPGA. And that because of like the energy and cost saving benefits of those, that those just grow to like dominate the space. And also like shout out to Polymer DAO also for publishing their Plonky 2 Circum verifier. That was very helpful for us in our early days. Yeah.
So you mean the hardware acceleration firm that produces the cheapest chips that allow a proving scheme to be really fast and really cheap? So like a hardware induced win, that would be fun actually. That would be. There's no way to predict. I guess there will be a winner, but there is no way to predict. It's way too early now. Even Nova is at its infancy, and people are saying, "Oh, folding schemes are gonna take over," but we don't know. So I think it's very exciting. I think also goes back also to the role of discussion is just everything is still up for grabs in a good way, like not for exclusive, but everything is still applied research. It's good that we have application because usually research takes tens of years because there is no application. Now there's lots of funds pouring into crypto, and it's kind of funds and money is essentially hard turboing the research. I feel that's kind of my take on. So I feel I'm very grateful for blockchain because it's accelerating the mathematical research of cryptography. So nice.
Yeah, agree. I do have some slightly opinionated views on the folding versus Stark, right? So I think one thing here people need to realize that at the end of the day, the ZK proof can work like magic. If you truly think about it, this is kind of magic, right? It's just like a very small number of bytes, you can compress so much computation, no matter how ginormous the computation is, right? So the Stark side of argument is like, hey, we're using smaller field, and this is like a memory, like a very fit into like the L1, L2 caches of the CPU very well. You get a lot of acceleration. And on the Snark side, the argument here is that, hey, we have this big field, and because we have a big field and especially on elliptic curve, we have this amazing homomorphic properties that you can essentially keep adding things into this kind of like a magic elliptic curve group. It didn't even explode, right? Just like single group, then you get a very dense representation. I think both sides are valid, but I think at the end of the day, if you're thinking from the entire system bottleneck point of view, right? I think everyone should realize the bottleneck of the entire system is bandwidth. That's in my view, right? Because that's really limited by the speed of light, and also limited by if we are assuming that everything in the blockchain space is going to build on this like a universal base layer Ethereum, right? So then I think the fundamental is going to be bandwidth limited. So I wouldn't say Stark and Snark, like which side will win, but we are actually very firmly doing that on the Snark side, purely because we want to solving the last mile problems. We want to building the proof aggregation. And I mean, we're very happy to, don't get me wrong, we're very happy to compress Stark proofs, like Elias said, right? Compress Stark proofs to bring more savings for the Stark project on Snark. But so we're kind of focused on NML, so we're basically using Snark most likely, yeah.
When you say bandwidth, do you mean like Ethereum throughput, like TPS, or do you mean bandwidth like Wi-Fi?
I mean general consensus bandwidth, because consensus requires synchronization of global state.
Okay.
And that synchronization of global state is inherently limited by the communication bandwidth, and this is kind of like there's information theoretical limit for this, and physical limit for this.
Kind of. So like for instance, we have like for each block, we have like people. So it's like a pseudo random number generator, you can imagine. But we assign people to, again, as I mentioned, like we can prove like transactions in parallel. We assign them to, you could imagine, something like different parts of a tree. We haven't released our white paper yet, so I don't want to say too much. But yeah. So anyways, like because of recursive verification, like the actual amount of data that each node that's doing the proving has to receive isn't like a terabit of data per second in order for our chain as a whole to hit hundreds of thousands of transactions per second, which we have on AWS at our great expense. So like I feel like the solution to the data bandwidth problem is just like log2, right? Like log-base 2 just like solves a lot of these issues. Because the one good thing, as you mentioned with snarks, is that you put a lot in and you get something small out. So as long as we've got a lot of logs occurring in this data stream, then we can fight like the speed of light with like exponentially smaller amounts of data coming from a exponentially growing number of nodes. So
Dirk, what do you think about that solution?
Now, I just wanted to add that, for a rollup solution, just Taproot itself, just one lever, right? There are also many other levers we can pull to guarantee, ideal developer experience and the user experience. So for Linea's perspective, I mean, the Taproot is just one focus area, whereas we're also trying to maximize our efforts in other areas, such as the liquidity bootstrapping for DeFi protocols, such as the stability experience for all the pen entertainment, pen social apps. So the Taproot discussion in our house is just one area where people spend time, and we do think there are many other levers that should attract people's attention.
For instance,
I just mentioned 2 examples, right? For example, for all the DAX protocols, given the lack of visibility of Linea native token, we got to inject the liquidity from both external liquidity providers and also our in-house dry powder, and also for all those pen entertainment dApps, whether it's gaming or social, we gotta use other tech tools and DApp tools to make sure the experience can be very consistent and very stable. So those are more like on the operational front, which we can think of. And then for the Taproot itself, I'm obviously not a bad person to speak on behalf of it, but we sort of come up with an innovative solution of neither snark or stark.
so on ZK,
shout out to Dirk for repping developer UX. Oh, I'm so sorry.
Oh, so for ZK enabled privacy, what do people think about this?
We could do KDF in circuit. So I can also, we have local proving because we can do things in parallel, so I can prove locally. So sensitive data only is like processed on the user's machine, and then we have like a per block or per update KDF. So we encrypt in circuit, and what gets published on chain is encrypted. So we are very bullish on privacy. Yeah.
Yeah,
And we
same
think,
here. I think
go ahead.
Yes, sorry, I will be brief. I think same boat here. I think fundamentally what we enabled is that we scale the ZKP verification, and a side effect is that your ZKP verification cost will be much lower. We were actually imagining order of magnitude drop in terms of ZK verification cost, and this is great news for the privacy-focused project, especially in DIDs. That's basically the user costs they pay for each ZK transactions happens on chain. So we do think it's kind of like a chicken and egg problems, right? So people keep saying, hey, like privacy is not there, but we think partially it's because we're lacking kind of infrastructure to truly lower the ZK verification cost on chain. That's exactly what we're working on.
And we think the benefits of privacy brought about ZK is exactly one of the reasons why ZK solutions can potentially be differentiated against op approach, right? And it can be, the use cases actually can be implemented at a very specific levels. So for instance, NFT owners can verify their ownership and authenticity without disclosing too much sensitive information or compromising their identity. So in the long run, this can mitigate the risk of fraud and identity theft, and ultimately really foster the trust and confidence among NFT participants. And if we take take one more step, right? So this kind of value proposition can really be translated into a very disruptive marketplace user experience in the long run. That's our view. And secondly, another example would be anti-counterfeiting across a lot of use cases, right? For gateways, for identity systems, for multiple asset classes in crypto world. So that can also be one of the value propositions. So overall, we think ZK is kind of arguably one of the most important tech approach to bringing the level of entire crypto security to the new height in the long run. But we're just in the middle of that, and fingers crossed for the long-term outlook.
I'd like to add something to what we are saying. I guess someone, the CEO of Zama once said something cool that I hadn't realized yet, is if you're using ZK for privacy, but the prover is going to access a centralized prover is going to access all the data. So this is something we have to bear in mind. Unless you're doing fully homomorphic encryption, your prover doesn't. Okay, Carter, maybe you have something to say, so I'd love to hear it. But as
we do local proving, so you prove locally.
But like, you need scalable. Okay, but
we have fast recursion. Fast recursion solves everything.
Yeah, exactly.
Yeah,
that's
local
what I'm
proving
going to
is
say
pretty
as
cool.
well. Yeah.
Yeah, local proving is pretty cool. So then local proving is very cool. It's not there yet, but it's going to be. So maybe let's take the point of view of a rollup. So for a rollup, you don't have local proving, and there is a centralized prover that's going to access all your data. So unless the field of fully homomorphic encryption is stabilized and complete, so I guess it should take a couple of years. I'm very bullish on it. But your encryption is as good as the prover has access to all your data when it's proving the things. So,
but local proving does work, and recursion is fast. So we don't have to wait for homomorphic encryption. Like, it works.
Yeah.
I can screen share.
No, but what I'm saying is
it's like 50 milliseconds.
Let me bring some data point, right? So I think a lot of people have this impression that these cloud machines have to be much faster than your local machines. It's actually the opposite. Because I'm an engineer, I actually did the benchmark, right? So more specifically, AWS X5 large machine, the proving will be slower than your M1 MacBook. Actually, if you really actually ran the numbers, right? So it's just like we don't. I think the bottleneck right now is actually the browser, because currently the browser can, because if you are doing the proving in the MetaMask or even in the Snap, right? The browser's like using this like a horrendous slow virtual machine called Watson, right? I think web GPU and folks are bringing like web GPU into the browser, and I do think this will be a game changer for the local proving by quite some margin. I think this is some like engineering problem. I would say it's pretty difficult engineering problem, but people know how to solve this kind of engineering problem. So if we can have more like attention of the industry and more resources putting into this kind of a client proving space, I do think a lot of problems can be solved. Sorry.
Yeah, definitely. But if you have to aggregate all those proofs, there may be also a problem of, say, networking. Because for a rollup, if you do local proving, there's at least a problem of standardization and adopting a standard altogether. So either someone wants to do a transaction, they prove it locally, and then they submit the transaction they want to do and the proof, and then it's accepted. But currently, this is not how it works.
I'll send you our white paper next week, and you could read all about it.
Yeah,
we have a standard. We have everything. We prove everything end to end, and I have like it's formally verified. So we have like everything expressed as constraints for all the different sub proofs. Really fast recursion is everything, and we are very excited that there are people that are working on like Shumo on solutions that can help recursion get faster and proof compression get faster. Because also, I think web GPU stuff, there have been some experiments. I haven't seen anything or heard even anything successful yet. There have been slow loss improvers, but who knows? Maybe someone will make a breakthrough.
But yeah, like I fully agree. So either fully homomorphic encryption in a couple of years or your local proving solution. What I'm saying is essentially we need to see it in prod. And I think there's a decent amount of time between a white paper and production widely used by users and a standard that the browser and local proving can do fast. That's why I'm saying we're not seeing it yet. And that's also why most chains have chosen a scalability part of ZK rather than privacy part of ZK, is also for that reason. And there are many challenges when doing an encrypted chain that you mentioned. And so I think definitely it's going to come in a couple of years. So, or even
2
less.
months.
2 months?
2 months to test
Wait,
it. Also, like, it's not so hard. It's not so hard. It's not so hard.
No, but look, it's now 29th of June. I love to see it.
Okay.
2 months.
I'll give you an E. I'll give you an E if it doesn't. And there is a chance that we will not launch by that. But we already, so we built the platform and then wrote the white paper. So the stuff we're already in a good place. But yeah, we only, I think, have one significant disadvantage, is that we are not compatible with the rest of the ecosystem. And we are focusing more on bringing in new applications, new use cases, and new developers to the ecosystem, rather than trying to cannibalize like the existing ones. Because like we don't support EVM, a parallel like system like ours can't support EVM. So I think like ourselves and Kakarot and Scroll and all of these other great projects, like we're just happy to work with each other. I don't think it's necessarily going to be like a cage match on like scalability or use case. Like there's probably going to be technical limitations for different use cases and trade-offs.
Definitely. I mean, coming from StarkNet, I feel you. The whole Cairo VM is not EVM compatible, and we've had to grow an ecosystem of builders that learn Cairo and learn a whole new toolbox and toolchain and just different way of thinking as well. So, I mean, good luck. And we can talk about it because network effect is both an overestimated, like overrated thing and also underrated thing. Because when you think about the L1 war, everyone lost kind of because of developer tooling, like Algorand included, because I used to be there. And so if everyone is saying there's only 15,000 or 50,000 Solidity devs, surely it can't be that hard to rebuild an ecosystem. It turns out it is. So yeah, I'm happy we love to see it. And StarkNet is trying to do it. I think they're doing a good job. We're doing a good job. So
why do you rebuild it though? Why not just like we support vanilla ES6 JavaScript. So all of the JavaScript tooling that isn't like requiring, different, like, I guess, features beyond like maybe like the proxy object where you can, anyways, like weird JavaScript features that were introduced after ES6, all the prior tooling just works. Like, why did you guys make a brand new language?
You mean Cairo?
Like, what was the point of that? Like, why did you do that?
I think it's essentially a language that's fully featured and thought out for the Cairo VM, which is like a Turing complete CPU that's provable.
So,
but there is an intermediate representation. Like we're going to soon be able. I mean, because we could have done two things, right? Like either build like a compiler from say Rust or any language to the Cairo assembly, or just write Cairo. So we started by Cairo assembly, which is the lowest level of the CPU thing. Now we've added like layers on top of it. So there's an intermediary representation called Sierra. And soon there's going to be a MLIR to Sierra. So you're going to be able to do the same thing. So in the end, it's a matter of why did we do it? Because it was the first thing we did. And we are gonna.
I don't mean to throw shade, but I do want to call attention that StarkNet has the greatest mathematical minds in the field, I would say, in the field of zero knowledge proofs. But perhaps it's more of a math lab kind of a crowd versus like a like hardcore engineering kind of a crowd. Yeah, DevUX definitely is probably going to win the day, right?
But like the research team is very math heavy, but all the builders are actually engineering heavy. So they're the one that are also directing some choices linked directly to blockchain stuff. So that's in the end, it works for a cool symbiosis. Like we call out when we think Cairo is not like a practical language, we call it out, and the fixes do come in. And one of the fixes is actually this intermediary representation where we're essentially going to be able to do Rust to StarkNet and Solidity to StarkNet. So.
Makes sense.
I think we're running out of time. So I would like to ask each of you, what do you think the biggest problem in the ZK scene is right now? And where do you think we'll be with it in 5 years' time?
I think the problem is, I mean, I don't know if it's really a problem, but it's like production readiness. So, I mean, it goes back to what I said, but everyone is on Optimism, Arbitrum, and Polygon POS because it just works. And it's low cost, fast, somewhat fast TPS. And people don't yet care about security in some weird sense, which is fine. And so the mindsets of engineers that say the best tech will win is not true. So I think this is one of the biggest problems is reality check. The best tech will not win. It's the best user and kind of narrative that will win. So yeah, and it will take a year or two to stabilize. That's kind of my take. So we are now in the applied research to prod kind of era, and in 5 years it's going to be money time for ZK. It's going to be everywhere. It's going to be even in Web 2. That's kind of my take. ZK is going to take over because, as Shumo said, this incredible magic thing about compression, and it has to be used everywhere. As long as it's battle tested, we trust that you cannot break a ZK proof. Then it's going to be the new way to just zip computation in a really meaningful way, and it's going to add so much composability to the web and blockchain. So it's going to my take. 1 and 2 years to go into full power mode and then take over, and then optimistic rollup. Optimistic way of thinking will not be a part of the world anymore. So I kind of suspect Optimism, they've already started to do it, and Arbitrum will just switch to ZK proof systems, and they've hinted the switch from OP stack and the ability to do zero knowledge proof. So I think everyone is just going to switch to ZK, and it's going to be great.
Well, from our observations, the largest headwind or challenge obviously being we just don't have first mover advantage anymore, right? Just as Elias mentioned, and the developer advocacy is a really meaningful challenge here. Yeah. And our take would be because, well, anyways, I think all the participants in this conference have felt that the consensus on Ethereum itself is strengthening rather than weakening. So rollups, holistically matter a lot. But ZK approach has a later start and slower development. If we look from the perspective of developers' friendliness, we believe that the emergence of Linea and EVMs at this time truly can potentially make the developers' life easier. Everyone can continue to use other tools and services that were used in the process of developing smart contracts on the Ethereum mainnet. The only difference now is that we can now technically achieve better throughput and user experience. And I also want to mention that, if we look from a mid to long-term perspective, continuing to use the ETH token rather than the L2 token to coordinate our production relationships on the rollup, we believe it might be the most sustainable way in terms of governance in certain market. And we have already come up with a lot of good ideas to solve the incentive problems during the bootstrapping stage. So yeah, that's our observation.
Thank you.
Yeah, I can be the next. I think just want to mention one number here. That's a number like I truly care is the number between native execution. Let's say you run a program in a state of art CPU or GPU to the number that you can efficiently you can run a prover. So you can see over the past 5 to 10 years, this gap keep shrinking, and I think we just need to take 1 or 2 or 3 years, and we reach to the scaling point, right? The scaling point is, let's say, this is like the proving time. The proving speed is only, let's say, 2 or 3 order magnitude slower than the native time. Then we will get a lot of adoptions for the entire ZK space. That's essentially why there are so many people who are so hyped about folding for the good reason, right? And specifically, what the recursion overhead of folding is about 4K constraint. Think about that, 4K constraint. It's truly amazing. That's why so many people are hyped about folding, right? So I think to us the biggest challenge is there. We want to be like Elias said, right? We want to be production ready. So we want to ship our V1 pretty soon, actually in 2 to 3 months in testnet. but we also want to sort of keep up with this super high speed train of the ZK technology developments. There is a like a kind of balance of adopting new research and also shipping code, right? And I don't think best tech will win. I think the best tech actually shipped will win. Yeah, you have to ship code. I mean, there's no other way. Yeah.
Absolutely. Definitely second all of those thoughts. ZK is going to make the internet a fairer place for users. So users will be less transparent with their data to platforms, and platforms will be more transparent with like their logic and the way that they operate their platforms, the platforms that we all rely on every day. Yeah, I think ZK is going to eat like the part of the world's compute that is like very valuable. Probably the succinct stuff or the simple but important transactions first, and then moving up from there. There's also one number I want to draw everyone's attention to, which is the price of an Nginx 0-day to the amount of money that can be gained by exploiting the Arbitrum-1 sequencer. So once there is a crossover in that number, then I can start just flooding all of the watchtowers with as many transactions as I want at a rate higher than they can process them. Once that queue reaches 1 day, ordering is gone. I can be submitting, transactions on behalf of others, especially on Nova. So Nova, I don't know if anyone knew, but the people with a reasonable botnet can take down like the PlayStation network for 20 days, hold it offline with their infrastructure. Do we really think that these optimistic rollups have the infrastructure to deal with an actual attack, like someone who's trying to benefit from stealing hundreds of millions of dollars? So yeah, I think optimism, I'm not very optimistic about their future as well. Friends don't let other friends have assets on optimistic rollups.
Okay, and on that note, I think that's all we have time for. Thank you very much.
Thank you, everyone. Thanks for having us. Bye.
Thank you.
Yeah, thanks for the organizer.
Thanks, guys.